Hi there, this video is going to be reviewing some of the power properties. So some of the rules of exponents can be a little bit tricky, so we're going to take a look at two different examples, and I'm going to show you multiple ways to solve them in hopes that one of those ways will stick with you and speak to you so that you can use that moving forward. So our first problem is the quantity of 4x squared, y cubed, all divided by the quantity of 2xy, all cubed. So just like in a normal order of operations problem, we have to do what's in the parentheses first and then the exponents. Well, if we look inside the parentheses, 4 times x, nothing can be done there. And 2xy, nothing can be done there. So those are just parentheses because they're applied to powers. So we have to apply the power. Well, when things are multiplying, we can actually apply the power to everything inside of the parentheses. So this 2 is going to go to both of these parts. So the numerator is going to become 4 squared x squared, and then the y cubed just comes along. All over. Well, down here, the 3 applies to all 3 parts inside. So we have 2 to the third, x to the third, y to the third. Now we have our parentheses eliminated, and we can start to simplify even further. So if we look at the numbers, we have 4 squared and 2 cubed. So 4 squared is really 16. And we have x squared, y cubed. And 2 cubed, that's 2 times 2 times 2, that's 8. And then we have x to the third, y to the third. Now, one of the strategies that you can use is to break this up and treat it like 3 separate problems. So we're going to do that first. So you could do 16 divided by 8 times these two. So x squared over x cubed. And then y cubed over y cubed. And this way it sort of separates it and takes our focus down to one thing at a time. So 16 divided by 8 we know is 2. X squared over x cubed. Well, one of the things that I like to think about when we're doing these division problems is that wherever the bigger power is, that sort of wins the fight. If you think of it like tug of war. We've got an x times an x up here, but we have an x times an x times an x down here. So there's really 3 x's multiplying down here, and there's only 2 x's. So that means that 2 of them are going to cancel out on both sides, and it's going to leave just one of these x's by itself on the bottom. So this is going to simplify to really 1 over x. And then the last part, we have y cubed over y cubed. Well, in terms of a tug of war, they're not going to be able to pull anybody onto one side because they have the same amount of y's on both sides. So it's going to sort of be a tie. So in this case, it's the same thing divided by itself, which is just 1. So now we put that all together. The numerators, 2 times 1 times 1 is 2. And the only thing that's on the bottom was an x, so we're going to leave it like that. So our final answer we get 2 divided by x. Now, if you don't like doing it that way, another way you could do this is at this point we could have broken it up into 16 and actually take the time to actually write out all of the variables. So x squared, x times x, y cubed, that's times y times y times y. And then down here we had an 8, and then we have 3 of each. So x, 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 y, y, y. And then with that, you just cross out anything that equals 1. anything that matches up. So in this case, we have an x on the top, an x on the bottom. X on the top, x on the bottom. We don't have another x up here, so we can't cross this x out. But we can do the y here, the y here. Here and here, here and here. So do you see how the only thing left over is the x on the bottom? And we know 16 divided by 8 is 2. So we could make the 2 over the x. So that's just two ways of showing you different methods of how to get the final answer. It's completely up to you how you do it, but you do want to make sure you show your work. All right, let's take a look at another problem. So this problem, we have the quantity of 2x cubed, all squared, times y cubed, all over the quantity of 4x squared, times y to the 5th. So just like over here, we want to make sure that we apply the powers first inside the parentheses to take care of that. So this is going to become now 2 squared. And then we have x to the 3rd, but then we're going to square that, times y to the 3rd. And then down here, this square gets applied to both, so we have 4 squared, x squared, y to the 5th. Now this introduces a new concept because here we have a power to a power. And we need to remember that when you have a power to a power, you multiply. So this is really going to be, well, 2 squared is 4. X cubed squared is really x to the 6th power. And then we have y cubed over 4 squared, well, that's 16. And then the other two come along, x squared, y to the 5th. Now again, if you want to think of this in two different methods, we could break it up. That's one of our methods. We could do 4 over 16 times x to the 6th over x squared times y to the 3rd over y to the 5th. So I'm just breaking it up by letter and by number. And then we could simplify and we could do that whole sort of tug-of-war game. So we have 4 over 16. That reduces to 1/4. Here we have x to the 6th over x squared. Well, again, if they're playing tug-of-war, x to the 6th is going to win because it actually has 4 more factors of x than x squared does. So that means we're going to have x to the 4th that's left over on the top, with really nothing on the bottom, so we can just put a 1 there. And then y to the 3rd over y to the 5th. Again, if we're playing tug-of-war, the y to the 5th is going to win because it's got 2 more than y to the 3rd. So we're going to have 1 over y to the 2nd power, because there's 2 more, and that stays in the bottom because they win the tug-of-war. And then we just put it all together. So up top, 1 times x to the 4th times 1. Is x to the 4th. All over 4 times 1 times y squared, that'd be 4y squared. So, just like over here how we did it the first way, we're going to do it the second way as well, where we list everything out. So, let's say instead we wanted to list and cancel. We could do 4 and then there's 6 x's. 1, 2, 3, 4, 5, 6, and 3 y's. And then down on the bottom, we have 2 x's and then 5 y's. So sometimes when you list out, you have to be a little more careful and make sure that you're crossing things out properly. So x and x, x and x. We can't cross any others out. Here we have a y, 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 and y. So do you see up top here we're left with those x's and we're left with these y's. Then, of course, 4 over 16, it still reduces to 1 over 4. But up top, we're left with x's. There's 4 of them, so we'll write x to the 4th. And then on the bottom, we have these 2 y's multiplying, so we write y squared. Of course, I have a 1 here. You don't have to put that 1. In fact, most of the time it's not there. It's sort of an invisible 1, but these two answers are the same thing. Okay? So take your time, make sure you show your work as you're doing these problems, and as always, if you ever need any help, you're always welcome to come visit me. All right, best of luck.